Hello guys and welcome back to my channel Civil Construction and Tutor, and in this video we'll be solving a numerical related to truss from engineering mechanics. So here we have a question: calculate all the member forces using suitable method. So basically we have two methods. One is the method of section and method of joint. So depending upon the type of question and the number of unknowns, the type of method is selected. So here we have the question that says to calculate all the member forces. So in this case the method of joint will be preferable, considering that all the joint in the truss member is to be considered, so it will be much more preferable. So here is the truss, and the truss is being rested on support A and D, where support A is the hinge type and support D is the roller type, and at point B there is a force of 20 kilonewton acting. Similarly at C there is a vertical load of 10 kilonewton and a horizontal load of 12 kilonewton, and at point E there is a vertical load of 50 kilonewton. We should always remember that the truss is always subjected to only direct stresses, and there won't be any shear force and the bending moment. That the truss is never subjected to direct shear force and bending moment. So basically truss is a structure which consists of member connected at the ends and are connected together with the pin joints. Similarly, all the external forces and reactions are applied only at the joints, and every member of the truss has two stresses, and there is no any, that is, it is not subjected to shear force and bending moment, it is only subjected to direct stress. And for now we are assuming that the self weight of the structure is negligible in comparison to the load they carry, so the self weight of the structure becomes negligible. Now let us start with the first step, that is check for static determinacy. Formula for checking the static determinacy: we have 2j is equal to m plus r, where j is the number of joints, and in case of our truss there are 5 number of joints: 1 2 3 4 5. Similarly number of members: 7, 1 2 3 4 5 6 7. And final reaction, considering this as hinge, so the number of unknowns 2, and similarly for the roller the number of unknowns is 1, so total number of reactions 3. So finally 2j is equal to m plus r, 2 into 5 is equal to 7 plus 3, 10 is equal to 10. Okay, so it is statically determinate. So if the value is greater, that is 2j is greater than m plus r, the structure is unstable, that is partially constrained. And similarly if 2j is smaller than m plus r, then the structure becomes indeterminate, overly constant. That is the overall conclusion of this equation. So the truss is stable. So now let us go to the second step, that is the calculation of reaction. So simply the concept that we used for the frame for calculation of the reaction, that will be applied for the truss as well. So for the method of joint or for method of section, we have to calculate the reaction and the remaining part will be different. So for method of joint, and here the we'll use the equation of static equilibrium, that is summation of fx is equal to 0, summation of fy is equal to 0, and summation of moment is equal to 0 at a particular point. Let us start with this, that is the summation of horizontal force is equal to 0, taking left to right positive. So let's assume rax in this direction, ray, and similarly rdy. Rax left to right. Similarly we have another horizontal force of 12 kilonewton acting in this direction, so plus 12 is equal to 0. Finally we get rax is equal to minus 12 kilonewton. So it is obvious that 12 kilonewton is acting in this direction, so to balance this force the reaction will develop in the right to left direction. So minus 12 kilonewton, the direction assumed is incorrect, so the force will apply in this direction. Similarly summation of vertical forces is equal to 0, taking upward as positive. So ray, rdy, these are acting upward. Similarly 20 kilonewton, 10 kilonewton and 50 kilonewton are acting downward, so those will be negative. ray plus rdy, minus 20 minus 10 minus 50 is equal to 0, and we get ray plus rdy is equal to 80 kilonewton. So this is basically an unknown equation. So for solving this we'll consider the another equation, that is equation of moment at a particular point taking anti-clockwise positive. So summation ma is equal to 0. Now considering this force, considering this point, we'll consider the moments. So firstly let us assume rdy, so this gives a anti-clockwise moment, so we'll take this value as positive. Similarly 50 kilonewton gives a clockwise moment, 20 kilonewton also gives a clockwise moment, and 10 kilonewton, 12 kilonewton, all these forces give a clockwise moment. So ray and rax won't produce any moment, considering there is no any lever arm distance. So rdy into 10, So 2.5, 2.5, 2.5, 2.5. So this is the distance, that is 10 kilonewton RDY into 10 clockwise, anti-clockwise. Similarly 20 into, okay, 12 into 4. So the vertical distance or the vertical height is 4 meter. 12 into 4 clockwise, that means negative. 10 into, so 2.5, 2.5, 2.5. So this is 7.5 minus 20 into 2.5. And finally we have 50, that gives a clockwise moment as well. So 50 into 5. We get RDY is equal to 42.3 kilonewton upward. So that is positive value. So the direction assumed is correct. Now coming back to this equation 1. So put the value of RDY. So RAY plus 42.3 is equal to 80. And we get RAY as 37.7 kilonewton upward. So the direction assumed for the vertical forces was correct. So finally we got all the reaction. RAX as 12 kilonewton, RAY as 37.7 kilonewton, and RDY as 42.3 kilonewton. So finally RAX, so this should act in this direction, so 12 kilonewton. Similarly RAY came as 37.7 and RDY came as 42.3. So this is the reaction calculation. Now let us go to the next step, that is the calculation of the member forces. So we'll be assuming method of joint, considering all the member forces has to be computed. And also there is one limitation for the method of joint, that is the method of joint is only applicable when the number of unknown member is 2, considering 1 point. For example, here the number of unknown is 2, that is the number of unknown forces or the number of unknown members considering this joint is 2. So this is this method is applicable. But if we consider this point directly, okay, without knowing these members, so here you can see we have 1 2 3 4 unknown members, or even this member, that is, or this point, that is we have unknown members 3, 1 2 3. So it cannot be solved by using the method of joint. So let's understand basic idea of the method of joint. So in method of joint, each and every joint is treated separately as a free body in equilibrium. Unknown forces are determined by using the equilibrium equation of forces summation fx and fy. We won't use summation of moment because, as I said, we'll consider this point as a free state in the equilibrium. So there won't be any forces that will create a moment. It is only applicable for members with maximum 2 unknowns, as I said. So let's start with joint A. So considering this as joint A, and we have 2 members in this direction, so the member forces will be RAE in this direction and RAB in this direction. RAE, RAB, and there is a force acting at joint A, that is the reaction 37.7, and similarly in this direction 12 kilonewton. So this is the joint A, that is the free body diagram at joint A. So again the same idea, that is using the equilibrium equation. So summation Fy is equal to 0, taking upward positive. So here you can see a member is in inclined position, so the force has to be resolved in horizontal and vertical direction. So with this angle theta, we can resolve this force. So this force RAB, the normal component of this will be the sine component RAB sine theta, and similarly the horizontal component will be RAB cos theta. Now let us compute the angle theta. So we are with this value theta. So theta is equal to tan inverse perpendicular by base. So considering this angle as 90 degree, so P is 4 meter, base is 2.5 meter. So on solving this we get 58 degree. So Fy RAB sine theta, so RAB sine 58 degree plus 37.7 is equal to 0. So now we can get RAB is equal to minus 44.45 kilonewtons. So this gives 44.45 compressive type. So the sign convention is negative value is the compressive type and positive value is the tension type. So summation Fy is done. Now similarly for the horizontal force, so you have to select the equation by the number of unknowns in that particular point. For now, if I had started with summation of fx, then we had two unknowns, that is RAE and RAB. But in the vertical direction, the only unknown force will be RAB, so I took summation of Fy first. So this is simple logic you can apply. Now summation of Fx considering horizontal direction, so taking left to right positive. So firstly we have reaction of 12 kilonewton acting from right to left, so minus 12 plus RAE, there is no any resultant of this, so just RAE plus RAB cos theta, that is the horizontal component of RAB. So RAB cos 58 degree is equal to 0. We get RAE is equal to, so taking to right hand side, so 12 plus 44.45 cos 58. Why? RAB is minus 44, so from minus and taking to right hand side we get positive value, so 44.45 cos 58. Don't get confused, we have to take the sign convention of the compressive force, so minus 44.45 cos 58, and we get this value as 35.5 kilonewton, and this is a positive value, there is no any negative sign, that means it is a tension. So this is a tension type force. So we are done with the first joint, that is joint A, and we have resolved the member force for AE and AB. Similarly, let's do for joint B. So here you can see the number of unknown would be 3. RBE and this being RAB. So this is an angle, okay? So don't get confused. And similarly there is a force acting of 20 at point B. So let us resolve this. Okay, let me draw another one so it will be easy to understand. So considering summation Fy, that is the vertical direction, we have two forces that has to be resolved. So this will also be 58 degree. Considering alternate angle, this will be 58 degree and this will be 58 degree. This is RBE, RBC, RAB. So considering vertical component, that is the normal component for the inclined member, we'll take the sine component. So firstly for RBE, so that means for this force considering this direction, so this will be negative, considering downward direction taking upward positive, so minus RBE sine 58 degree minus RAB sine 58 degree minus 20 is equal to 0. So all the forces are in the downward direction. So finally we get RBE. RAB, we computed this value as minus 44.45. So minus minus plus, and finally we get the value as RB as 20.87 kilonewton, positive value, so this will be tension. Don't get confused, RAB is in negative value, that is minus 44.45. so finally we get a tension value. Similarly summation Fx is equal to 0. Now we have to take the horizontal component of the member forces. So firstly RBC plus RBE, sine component was the vertical, now cos component will be the horizontal, so cos 58 degree minus RAB, because this is in this direction, so when we resolve this we'll get from right to left, so RAB cos 58 degree. Now substitute the value, RBC is equal to, taking this value to right hand side, so RB is positive value, so minus 20.87 cos 58 minus, so the value of RAB was negative, so minus 44.45 cos 58 degree, and finally we get RBC as 34.61 kilonewton, and this is a compressive type. So considering joint B, we have calculated all the member forces, that is RBC and RBE. Now let us go to joint E. So with joint E we can compute member force CE and ED, or even you can go with joint C and solve, because we have already calculated this member force, so we can easily compute these two forces. So for now let us go with this member and we can compute these two member force. Summation Fy, so considering joint E, okay, let me do over here. There is a downward force of 50 kilonewton acting. So this is RCE, RBE, RAE and RDE. So this angle is 58 degree, so will be this. Now considering summation Fy, considering the vertical component of the inclined member forces, so RCE sine 58 degree, so taking upward positive, so plus RBE sine 58 degree minus 50 is equal to 0. Now we can calculate the value for RCE because RBE is already known value, and RBE we computed this force as tension. So 50 coming to right hand side, this will be positive, minus 28.87 sine 58 by sine 58, the sine 58 from RCE, so we get 38.09. so this is positive value, so this means tension. Similarly summation Fx, we get RDE from left to right positive minus RAE plus the sine component, cos component of the two inclined members, RCE cos 58 degree minus for RBE minus RBE cos 58 degree is equal to 0. Now substitute the value of RAE as 35.5 kilonewton positive, and similarly RBE as 20.87, that is also positive, and RCE as 38.09, we get RD as 26.42, this is also a positive value, so this comes as tension. So we have calculated the member force for AB, AE, BE, BC, CE. Now we have to compute for, and similarly we have also computed for ED. Now the only member left is DC. So you can go for joint C or joint D, but for now let us go with joint D. So for joint D, so RDY we computed as 42.3, and the member forces will be RDE and RCD, and this angle will be 58 degree as well. So summation of Fx is equal to 0. You can also go with summation Fy. Considering Fy, we'll check the value later on. So for now let us go with summation Fx. So taking left to right positive, here you can see the direction as negative from right to left, so minus RDE minus, so the cos component will be right to left, so minus RCD cos 58 degree is equal to 0, and by substituting the value of RDE as 26.42, that is the tension value, so we get RCD as minus 49.86 kilonewton, negative sign, that means compressive type. So in this way we have computed all the member forces. Now let us cross check the process that we have done, it is correct or not. So for which, here you can see check. So we will do summation Fy is equal to 0 considering point D. So with the help of the member force that we have computed from joint A, so we will cross check the value at D. So summation Fy is equal to 0, and taking the normal component, so RCD sine 58 upward positive plus RDY is equal to 0. So this value should give equal to the reaction that will develop at point D. So RDY is equal to minus, so taking this value to right hand side, minus RCD being a compressive type, so 49.86 minus sine 58, so the normal component, we get this value as 42.3 kilonewton, which was the value that we computed while calculating the reaction. So the member force that we have computed from point A and coming to joint D is correct. So in this way we can cross check the value. So we will show the member forces in tabulated as well as in the figure. So starting with the member AB, BC, CD, and then we had AE, BE, DE, and finally we have CD. So for member AB, we computed the value as 44.45, that is compressive type. So 44.45 compressive. Similarly, for BC, we computed the value as 34.61 compressive. And for CD, we computed 49.86 kilonewton, that is compressive. AE was computed 35.5 and that was a positive value, so it will be tension. BE was computed as 20.87 tension, and RDE was 26.42, that is also tension, and finally RCD, which we computed, was 49.86 and was a compressive type. So now let us show in the figure as well. So member AB, compressive type. So for the compressive type, the force will act towards each other. So in this direction or in this way the compressive force is shown. So it is 44.45. BC, that is also compressive, so 34.61. CD, compressive, 49.86. AE, tension, so it will act away from each other, so this comes as 35.5. BE, tension, 20.87. DE, so this is tension, 26.42. and finally CD member is already done, so we have left CE. So this should be CE, and the member force for CE is 38.09, that was also tension, 38.09. so I made a mistake over here, just put CE 38.09 and that will be a tension force. So in this way the problem related to truss by using method of joint is done. I hope this video helped you, and if it did help, do like and subscribe.